Light, illuminating the earth and sustaining life on our planet. A physical phenomena that permeates our lives so completely that it isn't surprising that many people don't think about what exactly it is. According to the duality principle, light acts both like a particle or a wave depending on the circumstances. It is important to keep in mind, however, that the two aren't mutually exclusive. Before we get into that, let's look at how light acts as a wave. A wave is an oscillation or cyclic movement that carries energy while moving through space and matter. This is a sinusoidal graph that depicts the movement of light as a wave at a speed v. When the magnitude or height of the wave changes, as is shown in this graph, the brightness of the light will also brighten or dim. The wavelength and speed of the oscillation can then be used to find the frequency. Frequency is measured in cycles per second, or hertz. The frequency at which light moves determines the colors we see, as well as whether or not we can actually see the light at all. For example, ultraviolet and infrared light have a frequency that is either too high or too low for us to see. This shows the frequencies for several colors. As we discussed before, light is not only a wave, but a particle. Everything is made up of particles, one of the most fundamental of which is the atom. An atom is made up of even smaller particles, called protons, neutrons, and electrons. Light is made up of a different massless particle called a photon. When photons moving at a sufficient frequency hit certain materials, they excite the materials so much that the photons break the bonds between the electrons and the rest of the atom, resulting in something called the photoelectric effect. Increasing the brightness of light with a frequency too low to excite electrons will not have any effect, but if the light is already of sufficient frequency and the brightness is increased, the photons will break even more of the bonds between the electrons and atoms. The question then remains, why is it the frequency rather than the brightness of the light that makes it possible for the photoelectric effect to take place? The answer is because of energy. Frequency directly corresponds with energy when it is multiplied by Planck's constant, 6.63 times 10 to the negative 34th, so that when the frequency is increased, the energy hitting the atoms increases to the point where it breaks the bonds with the electrons. Wave, particle, energy. Light.